All right, good morning, everybody at home. Can I get a thumbs up that you hear me and see the board okay? Awesome. All right, here we go, guys. Cameras should be on. We are still in section 6.1. I hope to finish it today, give you a review tomorrow, and then you'll probably have a quiz on Wednesday, all right? This is by far going to be the hardest day, so please pay attention, and it gets a little technical, and our algebra skills are going to be put to the test. All right, here we go. On Friday, I showed you guys how to do a composition of functions. It's the fifth operation, right? If you're not going to add, subtract, multiply, and divide, then they're going to ask you to compose them, which it literally means you're taking one function and plugging it into another function. So I showed you it with numbers on Friday because it's definitely easier with numbers, all right? You work from the inside out. Today, we're going to see it with no input, where we're just working in terms of x. Okay, so the notation they use is f of g of x. I like it like this better because I can see x is going to go into g first, you get an output, and then that goes into f. You work from the inside out, all right? Or they ask you the other composition, g of f of x. Now x goes into f first, and then that goes into g last. All right, so look at example 1. Let me move mine up so we have room. I tried to start with a simple one just to kind of get the ball rolling. All right. We're going to let f of x equal the function 5x plus 7. So that's the mathematical expression that defines f. And then we're going to let g of x equal 4x. So two nice and tiny functions. All right, so let's say they ask you to find f of g of x. See how there's no number? They're not giving you an input. You have to work completely in terms of x. And each function is already in terms of x. So in reality, what's happening, if you work from the inside, first you're going to plug x into g. Well, guys, x has already been plugged into g, so that part is done, right? That produces an output. So then what you do is you take g of x itself. That entire function is going to get plugged into function f, where f has any x values. So guys, let's do this. Let's rewrite it like this. What did g of x actually equal? Who represents or who defines g of x? That's 4x. So in reality, you're finding f of g of x is 4x. So this is what you need to find. You need to go to function f and plug a 4x in for any of function f's x values. So literally, you're going to take 4x and you're going to plug it in to that x right there, the x that lives inside of function f. All right, so go to function f. Let's start rewriting it. It starts with a 5. So put a 5. Then it has an x. That x is going to come out, and 4x is going to be plugged in for it. So it's not 5 times x anymore, it's 5 times 4x. You've literally taken the entire g of x's expression, and you've plugged it in to function f, where he had an x value. And then continue on. It ends with a plus 7. So we've taken the function g, and we've plugged it into function f. Now all you have to do is clean up, right? So let's multiply. 5 times 4x is 20x's, and then plus 7 comes down. Do I have any like terms to combine? No. So that's your finished expression. That's what you get when you find f of g of x. You've plugged function g into function f. All right, so again, you can be sitting thinking like, I don't know, that wasn't that bad. Again, it's not that bad because the functions that we have aren't really complicated. 5x plus 7, 4x, they're not too bad. All right, now they can ask you to compose it the opposite way. What if they ask you to find g of f of x? So in reality, x is going to go into function f first, but guys, x already lives inside of function f. That part is done, right? So you're really taking f of x, the entire f of x function, and you're plugging it in to function g. So let's rewrite this as g of, who represented f of x? What did f of x actually equal? He equaled 5 times x plus 7. So you're taking the entire mathematical expression that represents f, and you're plugging it into function g. So you have to go to function g and plug this entire expression in for his x value. So that's what we're going to do. So go to function g and start rewriting it. It starts with a 4. So write a 4. Then it has an x. that x in function g has to come out, and this entire mathematical expression has to go in for it. So it's not going to be 4 times x anymore. It's going to be 4 times. Now we plug in 5x plus 7. So we've put the entire f of x function into function g. Now all I gotta do is clean it up. So let's distribute our 4. 4 times 5x is 20x. 4 times 7 is 28. You look to combine any like terms, but you don't have any, so that's your finished expression. That's what you get when you find g of f of x. How do we feel? We feel okay? Everybody all right at home? Thumbs up, we're all right with that? A lot of cameras off. Okay, so that's as easy as it's gonna get. Once they start having x squareds in their expression, that's when you're going to have to step it up a notch, all right? So let's look at the next 2 functions. Let's step it up. I usually find that when you find f of g of x or g of f of x, one of them is usually easier than the other. To plug one function into the other is usually easier. So it just depends on which one they ask you to do first. All right, let's look here. So now we have 2 new functions. Now we have f of x equals x squared plus 3x. So that's the mathematical expression that represents f. That's what you have to plug into function g. All right, and then you have g of x equals x plus 5. Thank you, Justin. All right, so that's the mathematical expression that represents g. So that's what you have to plug into f to plug g into it. All right, here we go. First, they ask you to find f of g of x, right? So first, x would go into g, but we already did that. X already lives inside of function g. Now you have to take the entire g of x function and plug that expression into f. So let's rewrite it. Really, we're finding f of, what did g of x actually equal? It equaled x plus 5. So that means our job is to go to function f and plug an x plus 5 in for any x that lives in function f. So guys, here's function f. He's got an x there, and he's got an x there. So our job is to plug x plus 5 there, and to plug x plus 5 there. We have to plug it into all of the x's that live inside of function f. All right, so let's go to it. So to start, you go to function f, and we're going to start rewriting. So if we go to function f, guys, it starts with an x. Take that x out and put in x plus 5. And then since that x was squared, this is now squared. We've plugged x plus 5 in for that x. All right, then continue writing. Then there's a plus 3, but it's not going to be times x anymore. This x comes out, and x plus 5 goes in. So now it's 3 times x plus 5. All right, so you notice, it used to be x squared plus 3x. Now it's x plus 5 squared plus 3 times x plus 5, because x plus 5 went in for x. All right, now getting it in is the hard part. Now we just got to use our algebra skills to clean it all up. So guys, remember, x plus 5 squared. You are not allowed to distribute an exponent over addition or subtraction. Think about how you square something. You times it by itself twice. So this is really x plus 5 times x plus 5. That's going to be a FOIL, okay? And then bring this down. We'll take care of this in the next step. Okay, so PEMDAS. PEMDAS says we definitely multiply before we add or anything like that. So guys, let's FOIL this out. X times x is x squared. X times 5 is 5x. 5 times x is 5x. And then 5 times 5 is 25. Perfect. So we FOILed that out. Now all we have to do is distribute this positive 3. So positive 3 times x is 3x. Positive 3 times 5 is positive 15. And now we just go through and we add all of our like terms together. So we should start with the highest degree one. So x squared, there's no other x squared, so it'll stay x squared. Let's do all of our x's. Well, guys, I have 5 x's. I have 5 more, so that's 10 x's. We're adding them together. And I have 3 more over here for a total of 13 x's. All right, and then your numbers. I have the number 25 plus the number 15. So plus 40. And you're done. And that's the expression that you are left with when you plug function g into function f. So to me, when you have these squared pieces, you might be making yourself some foils. And now you got to foil things out. So again, it just leaves a lot of room to make silly mistakes. All right, how did that one feel? Because that's kind of like on the more difficult side. Are we okay with that? All right, let's do the other one now. Watch how you feel. If this one was kind of hard, usually when you go the other way, it's not as hard. All right, so look at this one. They want g of f of x. So originally we're taking x and we're plugging it into f. But guys, x already lives inside of f, so that part is done. So what we really need to do is take f of x, the function, and plug it into g. All right, so that's really going to be g of, what did f of x actually equal? He equaled x squared plus 3x. So right here, this tells us what to do. We're going to go to function g, and we're going to plug this entire expression in for any of the x's that live in function g. So we're taking this, and we're plugging it in right there, because that's the only x that lives inside of function g. All right, so here we go. Go to g, start rewriting. G starts with an x. Take it out, put this in its place. So instead of x, it's going to be x squared plus 3x. I don't have to multiply with anything. It's literally x comes out and he goes in. And then keep writing, it ends with a plus 5. Do you have any distribution to do? No. Do you have any like terms? No, you're done. That's literally all you get when you plug function f into function g. Much easier. And that's because he wasn't squaring anything, so I didn't have to worry about that. Are you guys okay? Yes? At home, thumbs up, we're okay? All right, let's try the last two examples. I've given you two different functions. To me, this is probably as difficult as it's going to be. Okay. Well, they've used the other notation now. First of all, let's notice you've been given two new functions. This time they used f and h. F of x is equal to this, so this is the mathematical expression that represents function f. Notice he has an x squared in it, so when you plug something in, you're going to have to square that. He's got an x over there. That's another place you have to plug something into. All right, and then there's h of x. H of x only equals 4x plus 3, so he's a little bit simpler. All right, so that's the mathematical expression that defines function h. They asked us to find f of h of x. I'm not a huge fan of this, but guys, just work it backwards. First, x would go into h. He already lives there. Then h of x would go into f. That's what they're asking you. I still like to rewrite it first. This is f of h of x. And then you close parenthesis, close parenthesis. That's how you can rewrite it in the other notation. And this makes more sense to me. All right, so x goes into h. We did that. Now h of x is going to go into function f. All right, so that means it's going to be f of, well, who did h of x equal? Who is this h of x? It's 4x plus 3. Okay, so guys, this is our job. We have to go to function f and plug 4x plus 3 in for any x values that live inside of function f. So that means 4x plus 3 has to go there, and he has to go there. Those are the two x values that live inside of function f. All right, so to get started, let's go to function f. Let's start rewriting. Guys, function f starts with a -2, so write -2. Then there's an x. Take x out, put all of this in for x, so 4x plus 3. And then x was squared, so now this is squared, right? This took x's place. All right, then there's a -3. Then there's an x. Take that x out, put 4x plus 3 in. And then it ends with just a +7. So this is now what function f looks like when you plugged the entire function g in for all of his x values. So I'd like to think the hard conceptual part is over. Now we have to use our algebra skills to clean all this up. So guys, remember, in order to square this, I cannot distribute an exponent over adding and subtracting. So think about how we square something. We times it by itself twice. The square is only on this. So the -2 is hanging out in front, and then it's 4x plus 3 times himself twice. That's what that looks like. -2 times 4x plus 3 times 4x plus 3. Then we can bring down the rest of the problem. -3 times 4x plus 3, and then plus 7. Okay? Okay. So we have a lot of multiplying and then some adding and subtracting. We got to multiply first. So guys, can everybody go here? All right? We have to multiply -2 times this times this. Think about it. If this was 2 times 3 times 4, right? Let me use parentheses. All right, you would just do 2 times 3 is 6, grab the first two, multiply them together. And then 6 times 4 is 24, right? So you can multiply in any order that you want. I could have done 4 times 3 is 12, 12 times 2 is 24. So I need you, out of these three pieces, this is what we're going to concentrate on right here. I need you to take 2 of them and multiply them together. So do you want to multiply this FOIL together first, or do you just want to start in the front? So if we start in the front, guys, you're going to distribute your -2 to this first parenthesis only. Just multiply 2 pieces together. So if we do that, we're going to get -8x, right? And then what's -2 times +3? -6. And now I still have to multiply that with the 4x plus 3 that is left. Delta Math will probably tell you to multiply these together first and then clean it up and distribute. I think it's just easier. Grab 2, multiply, and then go to the next 2. Okay, now this we have to FOIL. This is going to be a FOIL. So let's FOIL this out. -8x times 4x is -32x squared. -8x times +3 is -24x. -6 times 4x is -24x. And then last, -6 times +3 is -18. Okay, so all that work, and we have multiplied the front part of the problem together. So guys, now we are here. Now let's distribute our -3 to this parenthesis. So what's -3 times 4x? -12x. What's -3 times +3? -9. And then the +7 just comes down. And all we have to do now is combine all of our like terms. All right, well, we should start with our x squared. The only x squared is the -32, so he just stays the same. Let me double check this is on screen. Yep, okay. Now we should do our x's. Well, guys, I have -24 x's. I have -24 more. That's -48 x's. Remember, they only cancel if they're opposite signs. If they're the same sign, add them up and keep it negative. All right, so -48 x's. If you want to keep track, we got -48 x's. Now we have -12 more. So -12 x's more, that should end at -60 x's. And then our just numbers. We got 3 just numbers. We had -18 and we had -9. That's going to add up to -27. But then you have +7. So now +7, -27 plus 7 should be -20. And there's your final expression from when you plugged H into F. So if you ask me, I think that's as hard as it's going to be. Because not only did you have to plug something in and square it, which means it had to FOIL, you also had this -2 in front that had to be multiplied in. So that's what I would suggest. I would just multiply the first 2 and then multiply it with the last one. Yes, go ahead, Thomas. Which one? This? X squared? Yeah. Okay, because when we FOILed this, I did -8x times +4x. -8 times +4 is -32. X times x is x squared, okay? Because we add our exponents. All right, so I think that's as hard as we're going to have to deal with. Now look at this one. So normally, if this one was that much work, to plug it in the opposite way, to plug F into H, usually doesn't take as much work. All right, here we go. So now they want H of F of X. So X should go into F, what he already did, and then you're plugging F of X into H. But I like to rewrite, this is H of F of X, and then close it, close it. So first, X is going into F, but we did that. Now we're taking the entire F of X function and we're plugging it into H. So really this is going to be H of, who represented F of X? All of this. All of this has to go into function H. So that's negative 2 x squared minus 3x and then plus 7. So guys, we have to take this entire expression and plug it in to function H wherever he has an X. But that's the only X that lives inside of function H. So that's the only place I have to put all of that. All right, so to get started, go to function H. Let's start rewriting it. Function H starts with a 4, so write a 4. Then we come to an X. This X is going to come out, and all of that is going in. Right? So it used to be 4 times X, but now it's 4 times all of that. And then don't forget to go back and finish it. It still has a plus 3 at the end. And now all we have to do to clean this up is just distribute the 4. I don't have to FOIL, just distribute your 4. And you're going to get 4 times negative 2x squared is negative 8x squared. 4 times negative 3x is negative 12x. 4 times positive 7 is positive 28, and then bring down the plus 3. And then the only like terms you have are your two numbers. Add your two numbers together. And you end up with negative 8x squared minus 12x's, and then plus 31, because they're the only like terms. And then this is your final expression. How do we feel? Guys, it's work. It's a lot of work, you know, one way more than the other, though. All right? At home, how do we feel? Thumbs up? Okay, so guys, I did give you a homework on this. It's on Delta Math. It's 6 questions, because I know some of these are going to take time. They're not going to ask you to do both. They're going to give you 2 functions, and they're only going to ask you to find f of h or h of f. You're not going to have to find both for every problem. Okay? All right, it's due tomorrow night at 11:45 on Delta Math. The homework from Friday, though, on Quizits. Remember, I made that due tonight. So if you didn't get that due over the weekend, you do have something due tonight. That was the 6-1 homework number 2. Okay, let me double check the attendance, and then I'll let you guys get out of here. And then, guys, as always, if you have questions, please reach out to me.